Hi everyone, today we are talking about the volume and surface area of cubes and cuboids. So to start off, let's review what two-dimensional and three-dimensional shapes are first. Two-dimensional shapes are those that you can easily just draw on a piece of paper. They have length and width. Okay, so if I were to draw a rectangle, boom, just like that, I have a rectangle. It has a length, we know how long it is, and it has a width, we know how wide it is. And those are the two dimensions. It can be drawn on a piece of paper, and it's flat. It lays flat on a piece of paper. Okay? Two-dimensional. A three-dimensional shape, you can also draw on a piece of paper, but then you actually have to add some depth to it. Okay? So it has three dimensions now, and we usually call that length, width, and height. These right here are three-dimensional shapes. So if you notice, you'll see a little bit of shading in to show that even though it is drawn on this piece of paper, in real life it's something that I can hold in my hand and it kind of pops out at you. It's 3D, three-dimensional. So if you were to draw a three-dimensional shape on your piece of paper, you do need to add in some depth to it to show that, oh, it's not laying flat. It's actually like a box where I can pick it up and look inside of it. There's space inside. It can contain things. Okay? So a 3D shape is a solid. We also call it a solid because you can put things in it. You can add water in it. You can add sand in it. You can add chocolate in it. So it has volume inside. A two-dimensional figure, like a rectangle, you can also add stuff in there. And we call that the area. You can fill it up, but really you can't fill it up with water or anything, right? Or sand. It's just going to be filled up with maybe just color, right? Or paint or something. Okay, so a two-dimensional shape, the space inside is called area. A three-dimensional shape, the space inside is called the volume. You also hear the word volume when we talk about sound, like, oh, can you turn the volume up, right? Because sound, as you know from science, you can hear stuff when the sound waves bounce off from your walls in a room, right? So that's why you can hear an echo in a really, really big and empty room. So that's kind of another way for you to remember volume relates to a three-dimensional shape, like a room, an empty room. Okay, so again, these down below are examples of three-dimensional shapes or 3D shapes. So we have a cube, which has the same shape, 2D shape on all sides, which is made up of squares. So 3D shapes are also made up of 2D shapes to compose that figure. A cuboid sounds like a cube, but it's just a fancy word for what is also called a rectangular prism. So instead of squares all around, you might have squares on opposite sides, but then you have rectangles on the other pairs. This right here is a triangular prism. So if you notice on the opposite sides, there aren't rectangles, but there are triangles. And you probably have seen this type of chocolate bar or packaging before at the store. Okay, so cuboid, which is just another word for this rectangular prism with the rectangles on both sides, and triangular prism, which has the triangles on opposite sides. Those are your most common three-dimensional shapes that you'll see in this chapter. Okay, so Now let's imagine cutting along some of the edges of the solids and we unfold it. What we get when we unfold it is called the net. Just like how you would use a fishing net to catch some fish, right? An open net, when you open up your net to catch fish, it is a two-dimensional figure. And then when you close it up to actually catch your fish, that's like your solid three-dimensional figure. So one is open and one is closed. When it's open, it is two-dimensional because it can lay flat. And when it's closed up, it is three-dimensional because now we have volume and we can contain stuff inside. So that's just where the word net comes from. It's what your three-dimensional figure looks like when you open it all up to expose the two-dimensional shapes. So a net of a solid is a plane figure, because remember, plane is like what you can draw or fit onto a piece of paper that can be folded up to form the solid. Be sure that that is in your notes. We utilize nets in order to help us do calculations. So it's not just a fun, thought exercise. What do we use nets for? We use them to calculate surface area. And we can use them to calculate volume, but most of the time they're very helpful, particularly for calculating surface area. We already talked about how the space that a three-dimensional solid occupies, the space we can fit inside, is called the volume, right? So you think about the volume of your voice inside a room, an empty room, and how your voice is going to bounce off those walls. That's the volume. Now, the other word is total surface area, or just surface area for short. So that's when we open up the figure, the three-dimensional figure, and we calculate all the areas of those two-dimensional shapes that make up the net. We open it up, and then we figure out the total surface area. Surface area, or area, usually is to figure out the area inside one shape, right? So it's called total surface area because now you have a whole bunch of shapes and you're trying to figure out the total area that is inside that net. A cube is, like we said, like a rectangular prism, but all the sides are equal, right? They look a lot alike. The cube just has all squares, and the cuboid has one side that's going to be a rectangle. So here is the net of a cube. They're basically 1, 2, 3, 4, 5, 6 squares, areas that are added together because that's the total. So then the volume of a cube would just be that. The volume of a cube, the surface area of the cube, we were talking about surface area with the net, would be all 6 of those areas added together, or 6x squared, if each of those sides were x. The volume, like we said, is the total area inside, and we always find that with length times width times height. Since they're all the same, it's just x times x times x, which is x cubed. So these two are really important formulas that you should have in your notebook. Volume is everything inside, so we're multiplying all those dimensions together to figure out what's inside, because normally the area of just a regular square would be x times x, right? But now we have a whole bunch of them, so we are taking each of these layers we're going to take each of those areas, and then it's repeated. So instead of x times x, to figure out one square, we're going to multiply by however many there are, which is x on the side. So that's why it needs to be multiplied. All 3 of those dimensions need to be multiplied. Let's take a look at this example. Find the volume and total surface area of a cube of side 3 inches. Go ahead and pause your video and try it on your own first. Okay, so we first need to find out volume. Remember, we said volume is just all your dimensions being multiplied together. It's usually length times width times height. Here, all of our sides are the same. So length is equal to that same side, width is equal to the same side, and height is equal to that same side, because a cube has all sides that are equal. So instead of length times width times height, it will be s times s times s, or s cubed. In this case, my side length is equal to 3 inches. So it's going to be 3 inches times 3 inches times 3 inches. Okay, 3 times 3 times 3 is 9 times 3, which is 27 inches. There's how many inches? 1, 2, 3. So inches cubed. So my volume for this cube is 27 inches cubed. Notice how the units is cubed. That's because there are 3 different dimensions. There was the length, the width, and the height. So our units is also going to have 3 as its power. Okay, let's move on then, and let's talk about the surface area. So the surface area, like we said, is when we add up all the different surfaces for your cube. Your cube has 6, like we said, squares that it's made up of. So we know we're going to have to take the area of one of the squares. Area is equal to length times width. And then since there's 6 of them, we have to multiply it by 6 because it's occurring 6 times. So 6 times s squared. 6 times each of the sides is equal to 3 inches. 6 times 3 inches times 3 inches. So this would be 6 times 9, which is 54. Inches times inches is inches squared. This answer has inches squared because when we open it up to expose its net, now it becomes a 2-dimensional shape. So your units also have to match with 2 dimensions. So you have 54 inches squared for the total surface area here. Let's look now at example 2 from your book. The total surface area of a cube is 150 centimeters squared. So they're giving you the surface area. You need to find the length of each side of the cube, and then using that, figure out the volume of the cube. Go ahead and pause the video and try this one on your own first. Okay, so they said that the total surface area is equal to 150 centimeters squared. Surface area is when you open it up and you expose the net. So we're looking at all the shapes that it makes up. We know that there are 6 total squares, and each square has an area of s squared. So it's 6 times s squared. So they're telling us that answer is 150 centimeters squared. Okay, so if the answer is 150 and we had to take s squared and multiply by 6 to get there, let's work backwards. So in order to get s by itself, so we're solving this equation, let's follow PEMDAS, or SADMEP, because we're working backwards, right? So let's deal with any addition and subtraction first. I don't see any. Let's go on to division or multiplication. Okay, this is being multiplied by 6, so let's divide both sides by 6, because you're working backwards, right? Normally you would multiply by 6. Now I'm working backwards to figure out what the original s value was, so I have to work backwards. 150 divided by 6. Let's see what that is. 150 divided by 6, that's 25. Okay, so that answer is 25 equals s squared. S squared means that s times s. Okay, and that s times s has to equal 25. So I'm basically square rooting 25. I need to figure out a number that would multiply by itself to get to 25. Okay, you probably already know that, or you could take 25 and square root that, and that's 5. Because the opposite of squaring something is to square root that answer. Okay, so s is equal to the square root of 25, which is 5. And let's check. If s is equal to 5, and this will be centimeters, if s were equal to 5, then this should work. 6 times 5 times 5 should give me 150. Okay, so each side is equal to 5 centimeters. Why is it just regular centimeters? Because each side only has one dimension. It just has a length. So that unit is just going to be centimeters to the power of 1. So that later on, centimeters times centimeters would give you the centimeters squared. Okay, so the answer is 5 centimeters. So if each side were 5 centimeters, let's figure out the volume. Volume was all that space inside. So we're going to multiply each of those dimensions, and there's 3, together. So s cubed. If it's s cubed and s is equal to 5 centimeters, then those 5 centimeters need to multiply by each other 3 times. 5 times 5 times 5. So that'll be 25 times 5, and that's 125. 125 centimeters times centimeters times centimeters is centimeters cubed. Makes sense because it's volume. Volume has 1, 2, 3 dimensions. Okay. Let's move on now to cuboids. So cubes were kind of easy because all their two-dimensional sides were the same. But a cuboid is a little different. And a cuboid is just a special name for what we normally call a rectangular prism. So if you see the word cuboid, don't be like, what is that? It's just a fancy word that your textbook likes to use for rectangular prism. I would say most people use the term rectangular prism, but it's good to know that it's also called a cuboid so you don't get confused, right? A rectangular prism has, it looks like a cube, but it has at least 4 of its opposite faces in the shape of a rectangle. So it's got a lot of rectangles. That's why it's called a rectangular prism. So here's the cuboid as a 3D folded up shape, and here's the cuboid's net when you open it all up. So it's just made up of a bunch of rectangles. Now, it's important to find the patterns that you see in the cuboid because that's going to make your life a little easier. So the pattern that I can see is that the opposite sides, opposite faces, are going to be the same. So we have this length times width rectangle. That's the bottom. So if you think about a box, the bottom of a box has to match up with the top of the box, right? Because if the top and bottom of a box don't match up, it's not going to make a box. It's going to be all folded weirdly, right? And so here is the length times width, the top and the bottom of the box. So you see that same exact rectangle twice in the top and the bottom. Okay. I'm going to write top and bottom. Okay. Now, top and bottom are the same. There are other pairs of faces that are the same as well. We also have the sides, this width times height. It's a little skinnier of a rectangle, but the sides also have to be the same in a box, right? This is the width times height. So it's these two rectangles here. They have to be repeated, or else that box is not going to close correctly. Okay, and then you probably guessed already, you have one last repeated pair. And that is, I'll use orange now, the one that we haven't touched yet, which is the front and the back. This is the length times the height. So we have the front and the back that are also repeated. We like this repetition. That means we don't have to do as much work later on. We can just solve one of them and then multiply by 2 because we see it twice. So these patterns are very useful for us. Okay, so we have the front and back. And then in blue, we have the sides. Okay, so we really just have 3 different types of rectangles, and then they're just multiplied by 2. Length times width, length times height, and then width times height. So each of them are kind of multiplied by each other. Length is multiplied by height once, length is multiplied by width, and then width and height. They're kind of paired up. Okay, so that is the surface area formula, which is right down here that we just talked about. And that's where you take each of the types of rectangles, you can add them all up actually, and then you just multiply by 2 because it's all being added up for the total surface area anyways. But notice how you have to add them up first, there's parentheses, and then take that answer and multiply it by 2. So really cool shortcut. We'll take a look at a problem like that later. Now with volume, just like with your cube, you're going to try and figure out how much space goes inside this cuboid. So all you gotta do is take each of your dimensions and multiply them all together. Length times width times height. For the cube, it was the side cubed, right? Because all those numbers were the same. Here, all these numbers might not be the same. So you gotta multiply each of them together. Okay, so volume and surface area of a cuboid, or also known as a rectangular prism, should be in your notebook. And we're gonna do some examples together. Okay, example 3. A rectangular block of metal measures 8 centimeters by 7 centimeters by 5 centimeters. So that's your length and your width and your height. Find the volume of the metal block, then find the total surface area. And then part C is asking you if the metal block is melted and recast into a cube, find the length of a side of the cube, giving your answer correct at 2 decimal places. Ooh, that one's challenging. Pause the video and try it on your own first. Okay, let's try A, find the volume. Remember, volume is multiplying the length times width and height. Here, they're all different numbers, 8 centimeters times 7 centimeters times 5 centimeters. Multiply those together. 8 times 7 is 56. And then we have to multiply by another 5. So that's 280. 280 centimeters, 1, 2, 3, cubed. That's our volume. Okay, and now let's move on to surface area. Surface area, if you remember, was where you had 2 times your length times width, plus width times height, plus what other pair are we missing? Length times height, right? Because we have to account for all 3 different types of rectangles there. And then there's going to be 2 of each of those. Okay, so 2 times 8 times 7 plus 7 times 5 plus 8 times 5. Okay, so each of those has to be paired up. I'm going to multiply these together first. 8 times 7, running out of space, is 56 plus 35 plus 40. Okay, so then I have to add all these together first. 56 plus 35 plus 40. Okay, that's all my rectangles areas added together. And then at the end, I take that 131 and multiply it by 2. So let me repeat what we just did because there's a lot of kind of order of operations going on. We first multiplied the length times width, width times height, length times height. Then we add up those products together. And then at the end, we're going to take the 2 and multiply by that. Okay, ran out of space there. 2 times 131 is 262. This is going to be centimeters squared because it is surface area. Surface area is only 2 dimensions, right? Because that's the net. Okay, so knowing that pattern makes it easier to figure out the formula. Now, part C. If the metal block is melted and recasted into a cube, we have to find the length of each side of the cube. Right now, it's a rectangular prism. It looks like this. We have to melt it down and change it into a cube. So think to yourself first, would I need the volume or the surface area when I'm thinking about melting it down and changing it into another shape? It's kind of tricky to think about. Yeah. So think about if this was, I don't know, made out of chocolate or something, right? If I were to melt that chocolate, would it be the outside of my rectangular prism of chocolate that I'm working with, or would it be the inside? It would be the inside, right? So we're looking at the volume here if we were melting it down. We're looking at what's contained inside. So we're looking at 280 centimeters cubed. That's our volume. We need to change this volume now, or not change this volume, still the volume, but we need to change the formula. So instead of our old length times width times height, we need to change it for a cube. A cube's volume is side cubed. Okay, so we need to now think of a number that when multiplied by itself 3 times, cube rooting it gets us to 280. Okay, you can sit there and try different numbers. Oh, is it 5 times 5 times 5 that'll get me 280? No. Or you could take that 280, put it in your calculator, and find the cube root of it, and your calculator would do that for you. Good thing we didn't sit there and try because it is a decimal number. 6.5421 yada yada yada. Okay, they want us to give the answer correct to 2 decimal places, so we got to round it. 6.54. 6.54. It would be centimeters because we're just talking about one side. One side only has 1 dimension. Let's check this. 6.54 multiply by 6.54, multiply by another 6.54. Should get us close to 280. It's going to be a little off because we rounded, but that's our answer right there. If we were to take the same volume and now melt it down into a cube instead, each side would be a little different, right? Because it's a different shape. That one was tricky. All right, let's talk about example 4 now. A cuboid is 11 centimeters long and 9 centimeters wide. The volume is 693 centimeters cubed. Find its height because they didn't give you one of the dimensions. And then B, find its total surface area. Go ahead and pause the video and try it on your own first. Okay, so they gave us the volume of a cuboid. Volume of a cuboid is length times width times height because not all the sides are the same. They gave us the actual answer for the volume, which is 693 centimeters cubed. They gave us the length, 11. They gave us the width, 9. They didn't give us the height, so we're going to keep it as h. Let's reduce this. 11 times 9 is 99 times h. So we're looking to see what number times 99 will get us equal to 693. Let's divide both sides by 99. Let's do the opposite, SADMAP. 693 divided by 99 will give us the answer. That's 7, okay? So the height is equal to 7 centimeters. So 11 times 9 times 7 will give us 693, the answer. Okay, that wasn't that bad. Now part B, find its total surface area. We're talking about a cuboid here. So total surface area would be equal to 2 times length times width, plus width times height, plus what are we missing here? Height times length. Okay, and then we're going to take that and we're going to height times length. We're going to take all those areas, add them together, and then multiply by 2. Okay. 2 times, let's see, length is 11 times my width is 9 plus my width is 9 times my height we got was 7 plus height was 7. I'm running out of room. Let me write a little smaller so that we can get all that in there. And let me, instead of using a parentheses, let me use a bracket to show that these are, separated. Length, again, was 11 times width is 9 plus width 9 times height 7 plus height 7 times length 11. All that, these pairs are going to be multiplied together first. So that's 99 plus 63 plus 77. I have to do what's inside the parentheses first. So add those together. 99 plus 63 plus 77 is 239. So 2 will be multiplied by 239, that total right there, that sum. 239 times 2, and that's for each of those repeated sides, 478. This is going to be centimeters squared because it's surface area, which is that net, so it only has 2 dimensions. It lays flat. Those are your 2 answers.